Hi, I'm an old guy and I do maths. Today we're looking at anti-differentiation, which is sometimes referred to as integration because it's easier to say. What is anti-differentiation? It's differentiation in reverse, essentially. So usually what happens is you are given the differential of an original function and you're asked to find the original function if you're just doing this as an exercise. There are obviously uses for anti-differentiation, and they're the subject of other videos. This is about how you do it, the basics of how you do it. So let's go to work. If we have an original function, x squared plus 5x plus 6, if we look at its differential, what we have here is we have an, which is that times the implied coefficient of x squared. So that gives us 2. We've subtracted 1 from that, and with 5x we have subtracted 1 from the x here. So that is 5x to the minus 1, which is actually 0, which is why that doesn't appear. So this is our differential here. And our job, as best we can, is to put this back into this form. That's an anti-differential. So let's go to work on that. Okay, so 2x plus 5, that's our differential. And what we're looking to do is we're looking to put it back into this form as near as we can. So essentially what we're going to do is we're going to reverse the process. Now bear in mind that this can be written as this, which is helpful when it comes to working with the anti-differential. So what do? Well, we multiplied x squared by 2 and subtracted 1 from the x squared. So if we look up here, what we did was we subtracted 1 from this, having multiplied this by 2. So we've got to undo that. So what do? Well, we add 1 to this power, and having taken that, we divide this expression by 2. Let me say that again. We put back the 1 and we divide this by 2. Now what does that do? Essentially it restores the 2 here and it gets rid of the 2 here. Over here we add 1 to our power of 0, which gives us 5x, and we divide by 1. Okay, now let's have a look at the language of this. So the instruction for this might look like this. So 2x plus 5 is the differential, and this is how we are instructed to integrate it or to anti-differentiate it. So what we've done is we've added 1 here and we've divided by 2, which gets us back to this. We've added 1 here notionally to the x to the power of 0, added 1 and divided by 1, which gets us back to this. Our problem is that we have no evidence here of what was here or whether there was anything here. So as a general rule, when you anti-differentiate, you usually wind up with C on the end. Just a note that there is a constant, or there may be a constant that you don't know about. Okay, so let's see if we can discern a general rule for this. So we'll stick with what we've got, which is 2x plus 5. And so we have what? We have ax to the n, and what we're trying to do is we're trying to get to the point where we have 2x to the 2 over 2 plus 5x to the 1 over 1. So what do we do? Well, we keep that, we add 1 there, and we divide by that. So this is how we get from our starting point, which is usually a differential, back to the anti-differentiated function. As a general rule, my experience is that this is slightly trickier than differentiation. Anyway, this is the very basic start of it, and I hope that you found this useful. We'll get into the actual uses of it in later videos. You're going to see this if you're in high school or doing maths at university. You're going to see this in a number of areas. Anyone dealing with even moderately advanced probability is going to see a lot of anti-differentiation. In fact, they're going to see what's usually referred to as definite integrals, which is a form of anti-differentiation that ignores this. Anyway, we'll get into that. I hope you found this useful. See you next time.